Okay, hi guys. Today we are going to talk about oxidation and reduction. So, these are two terms you should know already, okay, or at least have heard of. And I'll give you a quick reminder. Oxidation is when you form an oxide, okay? You add oxygen. Okay, and reduction is where you remove oxygen. Okay, and your examples here are, if we take, in fact, let's just do one big example. If we've got iron oxide, we react it with magnesium, it will turn to magnesium oxide and iron. So the iron here is losing oxygen, okay, so it is being reduced. The magnesium is gaining oxygen, so it is being oxidized, okay. This is a displacement reaction as well, because magnesium is more reactive than iron and it's displacing the iron, so we'll get solid iron out of the end of this reaction. In fact, we won't, because this reaction is so hot that actually the iron will come out molten. But we'll get pure iron, I think is probably more to the point. What we're going to look at today, though, is a second definition, okay, and that is what is oxidation and reduction in relation to the movement of electrons. Because don't forget, that's what a lot of chemistry is about, is the movement of electrons. So, oxidation is loss of electrons. Okay, and that spells oil. Reduction is gain of electrons. Okay, and that spells rig. So in order to help you to remember what happens about with the electrons in terms of oxidation and reduction, we've got this little mnemonic oil rig, right? That is, probably one of the first mnemonics I remember from science, or from any lesson, in fact, when I was a kid. And it still lives with me to this day. You'll be excited to know. So let me just draw a little oil rig there, just to illustrate the point. Bit of seawater. Now, if what we're interested in doing is having a bit more depth to your understanding of what actually is going on in terms of the chemistry here. So I'm going to give an example. I'm going to do it in this nice purple colour. So if we start off with CuSO4 and reacting it with iron, okay, that copper sulfate is aqueous and the iron is solid. Then what will happen is that we'll end up with FeSO4aq plus Cu solid. Now, Aq just means it's in solution, so it's a salt that's been dissolved. Okay, S means it's solid. So this, as again you'll see, is a displacement reaction. So you should be able to tell me exactly what a displacement reaction is. It's when we have a more reactive metal reacting with a metal salt, and the less reactive metal that's in the salt is kicked out and you form that solid, just like we showed you in the video yesterday. So this is called copper 2 sulfate. Okay, and this is called iron 2 sulfate. And that 2 there is important. Okay, and I'm going to show you why now. This sulfate, SO4, okay, which is sulfate, a sulfate group, it doesn't really do anything. It doesn't change. It's just attached to different things. So what we're going to do is break this down, okay, into something called an ionic equation. Okay, and that shows you the ions that are actually doing something, because that sulfate group, nothing changes about it apart from what it's attached to. Whereas actually we've got movement of electrons in the copper and the iron, and that's really what we want to get to. So that 2 tells us that this is a 2+ ion. So it's 2+, Cu2+, and that is Aq. Right? We're then reacting it with iron, Fe, solid, and it's turning into Fe2+. Oh look, iron 2, which is then aqueous, dissolved in water, plus solid copper. So what you could do here is you could actually demonstrate that by having a beaker, okay, and filling it with copper sulfate solution, okay, which is blue. And if you put in it a nail made of iron, okay, Jamie's going to absolutely love my diagram there, then what you will find is that over time you will get an orange colour appearing on the outside, and that is the copper metal being laid out on the, it's replacing that iron. That's why you see the copper colour coming there, and that is copper sulfate solution. All right, so you can actually see this, and when we get back to school then we will do that, okay, as one of the many practicals that we will have to catch up on. Okay, so let's get back to our equation. Here, if we're going from a 2+ to copper solid, right, we are gaining electrons. Okay, we're gaining electrons. In fact, we're gaining 2 electrons here, aren't we? Because that's 2 positive. If we add 2 electrons, each electron is negative. So that will balance that out and make that solid copper. Here, the iron is going from 0 to +2. So that one must be losing electrons. So if it's losing electrons, then it's being oxidized. If it's gaining electrons, it's being reduced. So the iron is oxidized and the copper is reduced. And we remember that because of oil rig. We're going to take it one step further, and then I'm going to let you get on with some work. Well, not that this isn't work, but let you show what you understand. In this equation here, we're going to break this down into something called a half equation, right? Which I'm going to do in this nice brown colour. Equation. So, the first half equation, okay, is that we're starting off with copper, Cu2+. We're adding 2 electrons, 2E-. Now, don't forget, this is aqueous. Electrons don't have state symbols because they're electrons, and it turns into Cu solid. Okay, and this one is our reduction. And here, the iron is going from Fe, solid, to Fe2+, aqueous, and it's giving away 2 electrons. Okay, and that's our oxidation half equation. Hopefully that's fairly self-explanatory. Those 2 electrons there, okay, they come from the iron, okay. and the iron is giving those electrons to the copper, okay, in order for the copper then to turn into solid copper. So it's just another way of just showing where the electrons go. Apparently my device is too hot, so the flash has turned off. Oh, and it's on again. Anyway, that basically tells us that time's up. Please go over this again if you need to. It is quite complex stuff. So don't panic if you don't get it first time. Keep plugging away at it. Have a go at the questions on the sheet. Hopefully you'll get it. Okay, any questions, please let me know. And I'll see you soon. Bye.